Hey everyone, I'm Benny Johnson, and this is my overview for my project 2. So I'll start with a quick code overview. See, there's some constants here, such as the clock rate for the Arduino, and the rate in hertz that I want to read, and also the rate in hertz that I want to wake up. I found that you can't do a 10-second delay with the built-in Arduino watchdog timer. So doing it this way, you can set how often you wake up, and most of the time you'll do nothing there. But whenever you hit this wake ups per read call, that will cause you to actually trigger a analog read. So moving on from there, this voltage to Fahrenheit function just takes you from 5 volts to a Fahrenheit output. Read temperature is the function that gets called for the interrupt. So this updates some of those global variables like your current time and your last Fahrenheit value. And then it sets this flag, which tells the main loop that it's now able to write things out. This setup function does some hard to read things here that set up the counters. Effectively, all this is doing is using those variables above to set how frequently the interrupt triggers. So in this case, it's triggering the wake up timer to happen 10 times a second. This is the actual interrupt call. You can see it mainly just calls read temperature, and then it resets this wake up timer. And then it also checks whether the wake ups per read is high enough to go ahead and do the next one. And finally, the main loop. Arguably, you could avoid having this loop entirely. You could just put this logic in the interrupt function in this case and do the serial writing there. Since to show you the general flow of how I would normally execute this on the software side, I have a script that would open up a terminal connection with the Arduino. I'm not going to run it here, but when you do that, you not only see the output from the Arduino, you also generate this temperatures.log file. And this is generally the output you're going to see. One of these lines pops up every 10 seconds with the last read temperature. From there, we can load that CSV file into Google Sheets, apply a simple function to round it off and subtract 10 to make the data look a little cleaner. But overall, it's the same data. And then generate this line plot on the right where we can see the temperature going and the elapsed time. You can see it's relatively cold on this data. That's partially my apartment is actually cold, and that's partially that the temperature probe in my sample is generally underestimated by about 7 degrees pretty consistently. So this clip shows how that was determined in the first place. You can see two different probes here, one that's an ambient sensor and one that is a grill probe, and they both showed about 7 degrees warmer. To confirm that this wasn't a strange probe behavior, I checked the main grill probe with both an ice bath and also a boiling water pot. And it seemed accurate on both of those and generally agreed with the other sensor. So it seems that the issue is coming from the TMP36 sensor as well. So again, it seems that the ground truth sensors are roughly correct. So this shows the process before, inside, and after I took the probe out of the fridge and the recording that went with each of those. And again, cutting back to our graph, we can see that that curve that we just showed in the videos is generally outlined here with the flat line at the beginning before it enters the fridge, a slow decrease as it enters the fridge and cools down, and then a slow increase back up at the end. So overall, it seems that the project was successful, and it does largely align with the ground truth sensors aside from the issue of the 6 degree or so offset that I'm unsure of the source of.